Hi everyone, Ram here. The idea behind this channel is to create a place where I can create content on my various interests, which mainly include mycology and technology, but we may explore other things in the future. Today we will be talking about creating a particle-free environment. While I am focusing this on mycology use, the same principles apply to other disciplines, such as creating a dust-free environment for electronic repair, like in the case of hard drive repair, or for hobbies such as bonsai cultivation. So let's get started. There's a lot of discussion online about the effectiveness of various methods of sanitation to prevent contamination and eliminate airborne particles from our workspaces. In mycology, all of the methods hope to accomplish one thing: preventing bacteria or mold spores from contaminating our mushrooms during the various stages of cultivation. While a laminar flow hood is the industry standard and the optimal way for cultivation, there are many other methods people have adopted over the years, based around discussions and experimentation by those on internet forums. Today, we will look at how effective some of the more popular methods are. We will use a particle counter in these working areas. The particle counter we are using for this experiment can effectively count particles as small as 0.3 microns, which should give us a good idea if there are any potential mold spores or contamination in our working area. The device is laser-based and reads how many particles are in the air per liter per reading. This measurement is called particles per liter, or ppl for short. When the run button is pressed, the device runs for 60 seconds, calibrates for the first 30 seconds, and takes 4 readings during the last 30 seconds in 10-second intervals. For effective readings, the device must be placed at a standstill. Movement of the device during readings can skew the results. We are mostly interested in small particles, so for these tests, we will be focusing on particles 0.3 microns in size. The relative humidity in my working area is around 50%. Keep that in mind for later. First, we will get some baseline numbers. We will start by getting some readings using a proper setup using a laminar flow hood. As we can see, we get 0 for all 4 readings, which is exactly the reason we use flow hoods for mycology. If we move back a bit, we get readings with more particles. This is the reason we work directly in front and center of our flow hood. For our next baseline test, we will test in open air. We will test in a living area with the AC on. Our initial reading shows 62,000 ppl. Subsequent readings show 60,000, 57,000, and 58,000 ppl, giving us an average of about 59,200 ppl. Needless to say, working in open air with the AC on is not ideal. For our next test, we will try a small bedroom where the AC has been off for a day. In this environment, we get an initial reading of 52,000, a second reading of 50,000, a third reading of 49,000, and finally 48,000 ppl, for an average of about 49,700 ppl. While a better result, it is still far from ideal. Now let's move on to ways that hobbyist mycologists attempt to reduce contamination without expensive equipment like a laminar flow hood, and test with our particle counter how effective these methods may or may not be. One method I have seen some people discuss is the unmodified bin tech. This tech utilizes a bin that is turned away from any possible airflow near the back of a wall, and the bin is laid on its side. The idea behind this tech is that the mycologist has more freedom with their hands and is able to work easier than in a still airbox. It is vital to have the AC off with this method. After cleaning the box, drying it, and letting it sit for 20 minutes. I placed the reader inside the bin. As expected, the results were not stellar. The readings showed 41,000, 37,000, 36,000 and 37,000 ppl for an average of about 39,200 ppl. While better than open air, it's not much better. Next, we move on to the still air box. This tech is without a doubt the most popular among hobbyist mycologists. There are many different trains of thought on this method and what is most effective, so I'm going to test the popular ones I have seen online. I am using one that I bought on Amazon some time ago for pretty cheap and used when I was getting started in hobbyist mycology. Properly built DIY boxes should have the same results. The first tech involves cleaning the entire still air box and then sealing it up, allowing it to dry, allowing any particles to fall to the bottom of the box. At this point, you work several inches above the bottom in the area that should be clean. But what I found with this method was less than ideal. The first reading was 42,000 ppl, and my humidity wasn't any different than my room. Subsequent readings were 36,000, 37,000, and 37,000 again, for an average of 38,000 ppl. I ran this several times off camera, with results that were all about the same. So I decided to move onwards to the next train of thought, keeping the entire enclosure moist with soapy water to try and keep particles stuck to the sides of the airbox. This method aims to keep mold and bacteria particles away from the working area, but it's largely theoretical, as we do not know how sterile the water droplets are. The hard part about measuring this method is that spraying the box increases the humidity greatly, resulting in water particles floating around in our still airbox. I decided to measure in several intervals, immediately after spraying, 15 minutes after, 30 minutes after, and 1 hour after. As expected, the readings were very high due to the high 70% humidity, with an average ppl of over 2.2 million directly after spraying. After 15 minutes, we had an average of over 700,000 ppl, and after 30 minutes, which is how long a lot of tutorials say to wait, we still had a high average of 275,000 ppl. I decided to wait a couple of hours until it looked a bit more dry. The humidity reading was still a bit high at 66%, and my reading showed an average of 74,000 ppl. My main concern around this method is that we are working with non-sterile water. I have seen other methods that replace the soapy water with alcohol, and I personally think that such a method would be much better, as spraying the walls with alcohol would allow bacteria and mold particles to stick to the solution and kill them. Any floating alcohol particles would be sterile ones. The main advantage of a still airbox is that we have an environment that is mostly free from outside exposure, and we should be able to have better control over the smaller amount of air volume, limiting possible contamination through sterile practices inside the airbox. These tests really began to make me appreciate my flowhood so much more, as I came to realize just how much room there is for error even using a still airbox. I believe the biggest advantage the still airbox gives us is by limiting the particles in the air to just the particles in the box. And we can potentially create an environment that has a reduction in potential bacteria or mold spores through cleaning. But I felt there had to be another option, so I delved down the rabbit hole to create a cheap tech that could create an environment with zero particle readings. This is where my next idea came to fruition. While browsing Walmart the other day, I saw an air purifier on clearance for $40. What caught my eye was that it also came with a true HEPA H13 filter, which should filter out particles 0.3 microns and larger. And it had 3 speed settings. While such a device does not create laminar airflow, I thought I'd snag it up for an idea I had. To start things off, I wanted to see what the readings would be if I were to theoretically just work in open air directly in front of the filter at various speeds. The area in front of the filter was very small, so I tried taking some readings a little further back. Due to the fact that this device cannot create true laminar flow, turbulence in the air will result in some surrounding air mixing into our pure air. My results were surprisingly good. At speed 1, we had an average of 3,500 ppl, which meant we had a reduction of 93% of particles compared to working in open air, and a 91% reduction of particles when compared to working in a still airbox. We had even better results directly in front of the flow, with an average of 1,700 ppl. At speed 2, we had even better results, with an average of 1,400 ppl further away from the airflow, and an average of 1,200 ppl close to the airflow. At speed 3, we saw our best results yet, with an average of 933 ppl further away from the airflow, and 266 ppl close to the airflow. But this was still far from where I wanted to be. A place where I can confidently say my work area has close to 0 ppl and a big enough working area that I would not be super limited. And considering we are moving around in open air without purified laminar airflow, we are always potentially exposing ourselves to contaminants from an area we don't have control over. So, I decided to experiment. My first idea was to push the clean air into an unmodified bin and record the particles inside the bin. The results were not stellar, as I got an average of 1,477 ppl. There is still a lot of disruption of air in and around the bin, particles that we have no control over their cleanliness. So this is where I decided on my next idea. I took my $40 Walmart air purifier. I cut the end of a Walmart bag and taped it with Walmart packing tape. I then taped the Walmart bag to my still air box, which has an airflow feature that lets you allow some air exchange. I opened both ports, turned my air purifier on, and let it run for a few minutes at full blast. With the purifier continuing to run at full blast, I took some readings in the center of my still airbox, where I would typically be working. I recorded an average of 156 ppl, with 2 readings of 0 ppl. At this point, I was so close I could feel it. I was close to the 0 ppl I desired, but I also wanted 0 ppl with my hands and arms in the still airbox. So for the next test, I turned the air purifier off. I closed the rear vent and put my arms through the armholes. I was able to get an average reading of 64.5 ppl, even closer to my goal. I then proceeded to turn the airflow to 1, put my arms through the armholes, allowing air to flow out of the airbox through the armholes, pushing air away from my arms and hands, and turned the counter on. And it happened. I got 4 readings of 0 ppl, my average of 0 ppl. I couldn't believe it. I tried several more readings, and the highest reading I got on occasion was 20 ppl. Moving my hands over the sensor did increase ppl readings. This is why it is so important to keep your hands to the side of your working area and to not allow your hands to move over the culture you are working with. Even with clean gloves, this can introduce contamination if you were working directly over your cultures. But with this, I found the laminar flow hood free tech. In my opinion, the ultimate budget-friendly fake laminar flow hood, which I dub Rems Walmart Fake Laminar Flow Hood Tech, or Rems Walmart Full Hood Tech for short. One of the best advantages of this tech is the freedom to move in 3 dimensions, as you theoretically should have clean air throughout the entire box, where, as with a laminar flow hood, you want to always work as close to directly in front of the hood as possible, and you need to ensure you work towards laminar airflow, which limits the direction you can work in when you want to do things like open containers or dishes that need to be kept sterile or set up syringes. With the full hood tech, you should theoretically not have to worry as much about these kinds of movement restrictions, and instead you would focus on not working directly over your cultures. Of course, with a proper laminar airflow hood, you do still have much better visibility and have better freedom of arm movement, but considering the full hood tech costs under $100, the cost savings is tremendous considering the benefits it does provide. But this is all based on readings and theory. I do have plans in another video that will put these theories to the test. So subscribe and stay tuned as we plan on using Eiger plates to try and test real-world results on various methods. I will be reading comments and am interested in what you want me to try and test. So make sure to comment and I will see what I can do. Bye for now.